Hello and welcome to another video. In this video we're going to be working on smallest range covering elements from k lists. And in this one you have a k list of sorted integers in non-decreasing order, and you want to find the smallest range that includes at least one number from all of them. And this part is a little bit confusing, but basically what you want to do is you want to find a range that includes at least one number from all of these, and then if two ranges are the same length, basically they're telling you you want to pick the smaller result. So for example, if 20 and 24 worked, but also like 0 and 4 worked or something, you'd want to pick this one because they're the same length, but you want to pick the smaller one. At least that's how I read it, because they tell you this here. Like, if A is less than C, but the ranges are the same length, you want to pick the smaller one. So yeah, so for this example, so you have these lists, and I do think this is like honestly kind of difficult to understand, but basically, yeah, you want to make a range that is the smallest possible. And like I said, if there's two that are the same distance, you want to pick the one that starts with a smaller number. And this range has to include at least one number from all of these lists. So like this 20 through 24 does include 24. And now the number doesn't have to be one of these two, but it has to be in the range. So that's another thing. So 24 is in this range. And here 20 is in this range. And then here 22 is in this range. But you can have multiple as well. So like, for example, if I pick the range 430, that could have everything. And if that was the smallest, that'd be fine. Yeah. So one thing to notice here that you can kind of prove, I guess, is if you have a range like x, y, x and y will always be in one of these things. Because if they weren't, like let's say we have some numbers, like let's say some number out of all of these is in this range, and let's say like the smallest number out of all of these that's in this range is like x plus 2, and then the biggest one is whatever, like y minus 2 or something, let's say, right? So if my range was like 20, 30, but then my numbers, like let's say the numbers that are in this range out of all these are like 22, 24, 26, whatever, and I want to make sure that all of these are in the range, you can always just shrink this, right? You can always shrink this to just be, this is going to be the smallest now, and this is going to be the biggest. So that basically guarantees that the bottom and the top of the range are actual values in here. So that's important to recognize. So you don't want to just like manually build a range. You actually want to use numbers in here, and some combination of those numbers will give you this. So in the second example, it's 1, 1 because 1's in the range, 1's in the range, 1's in the range. Also, something like 2, 2 would work, but 1, 1 is smaller, so that's the answer. That's why there's not like multiple solutions here. But yeah, it's difficult to come up with how to do this, and I think there's like 2 or 3 ways to do it. But basically, the way you want to do it is you want to think like, okay, if I have some range, x, y, and I know this is like a possible solution. For this x and this y, if I replace y with numbers that are bigger than y, or actually no, if I replace x with numbers that are bigger than x, then my range can get smaller, right? I guess. Yeah. So like if I replace x with, x plus 5 and so on, then my range can get smaller. But I know I need to use some combination of these numbers. And so basically what you want to do is you want to replace numbers with like the smallest number possible. Because if you don't replace numbers and you just make y bigger, right? Like if I have some number stored and I have like x, y, and I just make y bigger, given this x, that range will never be better, right? Like x and y plus something will never be better. So what I need to do is I need to try to replace x with numbers that are bigger than x. And then see, like, can I make something better? And then you want to do a smart replacement where like you are replacing numbers, but you also want to ensure that like at least one of these is still always in your, like set of numbers you're using. And so one of the ways to do this is we can just take the smallest number from each of these and make like some kind of data structure, and then figure out like what's that range. And then we can just say like, if we want to replace one of the numbers, well, which one would we want to replace? And the answer is we want to replace the smallest one, because that one gives us the biggest range, right? So if I have some numbers, like if I have one of each of these numbers and the numbers like 2, 20, 30, 40, well, how do I shrink this range? Like how do I ensure that I check everything? Like if if I keep the 2 but I get rid of the 30, that doesn't really do anything. It doesn't really shrink the range, right? So to actually shrink the range, I want to get rid of the smallest one. And then what do I want to replace it with? Well, there might be some combination that you might miss. So like, let's say I replace this 4, like this is the number I'm using from this array in my range. Well, what am I going to replace it with? Because these are sorted, I can just replace it with like the next one. And so we can keep doing that. We can just say like, what's the smallest number? Let's just replace it with the next number in that list. And then eventually we'll hit some combination that'll work. So let's kind of walk through that. So there's a couple things we need to store here. So first we need to store like our result range. So for that, we can just say like, you know, the min of the range and the max of the range is going to be our range. So I guess we can just define our range as like, you know, -infinity to infinity. And then we're just going to try to make this smaller. And we also need to keep track of the biggest number in our list, because when we pop off the smallest number, we're going to need to see like, okay, given this smallest number in the array, our range is the smallest number to the biggest number we currently have. So we're going to store like a current max, and we can initialize this to like -infinity, and we'll try to maximize. And then the rest of it is we just take the smallest number in each of these, and then we're going to keep popping off the smallest number. So what's the data structure that we can use to keep popping off the smallest number? It's going to be a heap. And then like, what information do we need? So we need to be able to pop off the smallest number and then go into the array that that number was in and then get the next one. So we need to know the actual value. I mean, we don't really, well, yeah, I guess I mean, it depends how you make it. You don't really need it. You can just have an index, but we'll have a value. We'll have an index in the actual, like which array it's in. Like this is array 0, this is array 1, this is array 2. So we'll call this like I, maybe. And then we'll have another number that's like, what is the actual index in that array? So like for 4 would be array 0, index 0. So I guess we can call this like J or something. And this is what we'll have a heap of. So let's kind of walk through how this is going to work. So basically our initial heap would be, we're going to take the first number out of all these because they're sorted. So we're just going to take the smallest one out of all of them. So it would be like 4, 0, 0. I guess we'll store it as a heap so you can visualize it better. So 0, and then this is array 1 at index 0. And then the last one is 5. Array 2 at index 0. Okay. And then as we put these in, we're gonna write down like what's the biggest value we've seen so far. The biggest value was a 5. And so the range with this heap is basically the smallest value in this heap to the biggest value we've seen so far, right? So we can say like, okay, well the range here, we're just gonna pop off the smallest value, which is this one here. Yeah, so we're gonna pop off this value here, and what's this range? So this range is 0 to 5 now, because that's better than our old range, and our current max is still 5. And then for this value, so I guess we can even show it. Yeah, so we can say like these are the ones we used already, and now we popped off the 0, and so this 0, the next value is over here. So then we're basically going to replace that value with this value. So this will be 10. And this is, actually, no, it won't be 10 because the 0 is over here. Yeah, so definitely not that. So it'll be, yeah, it'll be 9, right? Because that's the next value of the 0. And that's in array 1 at index 1. And we put this into the heap. And I guess I'll just show the heap like this. I'm not going to keep like sorting it because that's going to be annoying, but this is our heap. Okay. And then we're going to do the same thing. So we put in a 9, so we'll update our current max. And we'll see, like, is this range better now? So this range is now, we're going to calculate the range as soon as we pop off a value. So to pop off a value, we're going to say, okay, let's just pop off this now, right? Because this is the smallest value. So we're going to pop this off, 400. Yeah. And then that's over here. And what was that range? So it's 4 to 9, which is, yeah, which is the same width as this, I guess, right? 4 to 9 is the same width as this, but this is the bigger number. So like this 4 to 9 is the same as this, the same width, right? It's still 6 numbers, but this starts with a smaller number. So in case of a tie, we just keep the other one. And then 4 to 9 is, yeah, so we pop off the 4. So what's the next number for the 4? So the 4 is, probably shouldn't be deleting these actually, because then it's hard to see. Yeah, let's just do it this way. So the next number for the 4 is 10. So we're going to put that into the heap. So it'll be 10, array 0, index 1. And we're going to update our current max to be 10. So we'll keep doing like a few more of these and then stop, because you kind of get the idea. But basically you'll get to the point where you're going to run out of numbers, and then you can never have, you always check like, does my heap have one from all of these? And the way to check is just, is my heap length the same as this length? Because I'm popping off one number from one of these arrays and then putting on the next one. And if I can't, then I'm basically done. Okay, so now we do the same thing. We pop off this one. And what's our thing? It's 5 to 10, which is the same as this, but this is smaller, so we're going to keep that. So what's the next one for the 5? So the 5 is 18 at index 1. And we're going to put that in the heap. Then we're going to pop off the 9. And when we put in the 18, we're going to update our current max. So the 9, our biggest range is, or our current range is 9 to 18, which is bigger than this. So, so yeah, so actually we can probably get through the whole thing, just do it quickly. So for 9, the next number is 12, and it's at index 2. And our current max is still the same. Yeah, so our current max is still the same. So 12 at index 2. And we're gonna move this over here. This is the next number we'll pop off. So for 10, the next number is 15. And our range is 10 to 18, which is still, we're not beating this yet. So 10, 15, index 2, and array 0. Then the next number we'll pop off is this one. And this range is 12 to 18, which we're still not beating what we have. So 12 goes to 20, and index 3. And now our current max is 20. And this is here. Then we pop off the 15. And our range is 15 through 20, which is the same as this, but this is smaller, so we're not using that. So 15 goes through 24 at index 3. And our new current max is 24. Then pop off the 18. This goes to 22 at index 2. Let's move this over here. This over here. This is our heap. Okay, now we pop off this guy, and this is where we get our better difference. So here our range is 20 through 24, which is better because it's smaller. So now we update 20 to 24. And then we take this value, and there is nothing after this value, right? Like this is this 20. So there's nothing to update in here. So now our heap only has 2 elements, and then we're done. Because now we no longer include everything from all of this. So you can see we're like smartly getting rid of the smallest number and keep putting in the next one. And then we're always going to get a combination that will give us our best result. And in this case, actually, we're going to put in a 1, and a 1. And then when we pop off the 1, our range will be 1 to 1. Because our max will be 1, our min will be 1. So that's kind of how that works. Yeah, there's probably other ways to do it, but I think most of these problems and the ones for the last few days, heap to me is most intuitive. So that's the idea, is we're going to maintain a min heap. We're going to populate it with the smallest number in all of these. And this problem is kind of similar to where there's some problems that you have a linked list of these things, but now you have an array. So you want to think about like, okay, if I have an array and I have some element in the array, how do I get the next one? Well, you just need to know the index of the array and then the index within the array. So that's why we're storing 3 things. So here's the code, pretty straightforward. So the reason by the way, so in Python, I would just initialize like range min and range max to float infinity and float negative infinity. But in Java, if you do the actual integer max val, right? Max val minus min val, that'll give you an overflow because this will be bigger than max val, right? Because you're basically, min val is like negative max val, so you're basically saying, give me max val times 2, and you can't have max val times 2 because any number bigger than max val in Java will be an overflow. So I just defined my own max val. I just look at the constraints. I think it was like 10 to the 5th, so I just made it 10 to the 6th to make sure I didn't get an overflow. So my starting range will just be this. My current max will just be this, just to make sure I don't get any overflows, or you could use longs. And then you make a min heap, and it's a pretty standard min heap. In fact, I don't even think I need this comparison. Maybe it'll ask me for one. So yeah, I think we can just get rid of this because like we're just doing a standard min heap, so I think this is the default behavior. So let's see what happens. Yeah, I don't think we need it. Okay, and then we basically just take the smallest item in every single one of these lists and put it in. And then we update our current max every time to be the biggest of those. And then as long as our heap size is the same as this num size, then we keep doing this pop off the smallest element, get its value, its list index, and its num index. Check, is this range smaller? It has to be strictly smaller than the one before, because as we keep making new ranges, their min and max values will be bigger than ones before, right? Because we're always popping off the min and then like increasing the max. So this has to be strictly smaller. And then we just check, can we move to the next value? So that's pretty straightforward. You just get the index, and if the next one is in bounds, we get the next value, we put it into the heap, and we update our current max again to be the biggest of what we put in so far. And then we just return. So pretty straightforward. I do think it's a pretty tough problem though to come up with this kind of stuff. And honestly, the problem description was kind of bad. I think it took me like a few minutes to figure out what exactly they meant. But once you realize like my range is some combination, ooh. Okay, I guess we do need a compare, because I think for default compare it has to be like some kind of like primitive or something. So I think we do need a compare, I guess. Don't use Java too often for this kind of stuff. Okay, so yeah, so pretty easy compare function. You just say like, we're just comparing based off the first value in the array, the other ones don't matter. And yeah, so once you realize that the range includes these numbers, you just have to figure out like, okay, how can I smartly traverse these? I think the other way to do them is like a sliding window, and you just, all of these numbers, you kind of do the same thing. You say like number and then array index, and then, yeah, number and then array index, and then you sort, and then you just like make a sliding window of like, you make sure your window is always has a number from each of these arrays, and it works kind of the same way as the heap. So that's like the other way to do it. But I think for most of these, I just use a heap. Like whenever you're asked to get like, the smallest number, generally just use a heap, and it's pretty straightforward. Okay, so here, this is n log n. Is it n log n or like n log k or something? Yeah, I guess it's technically not like n log n. Like if we say n is the length of this array, I guess, let's see. Num's length is k, okay, and then num's length, yeah. So let's just say num's length is k, and then the length of each of these arrays, are they all the same? I don't think so. I don't think they have to be the same, right? Yeah, like this has 5, this has 4, and so on. So basically, let's just say the number of numbers we have to go through, worst case, is like, let's say k is like the number of arrays, and the length of an array is n. It's probably like n times k or something. Yeah. And then for each of these arrays, we're basically doing stuff with the heap. So it'll be like log, and then the most numbers you can have in a heap is k, because you're going to have one from each, something like that. And then space will be like of k, something along those lines. Yeah, so that's going to be all for this. Hopefully it's helpful. Yeah, I've been kind of busy, so I didn't do that many problems lately. I probably won't do that many in the next couple weeks, and then I'll have some more time, so then I'll do more. So thanks for watching, and I'll see you in the next one.